Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Our today's topic is the continuity of the previous one, miscellaneous series. Dear students, in the previous lecture, I have developed two main formulas, and those were the two formulas about the summation of n number of first n natural numbers, and the second one was the sum of the squares of the first n natural numbers. And today's topic, we are going to derive formula for the cube of first n natural numbers. And these things I am going to develop because these formulas will be utilized in this particular chapter to find the sum of the given miscellaneous series. So let's start and to derive that what is that formula is for the summation of the cubes of first n natural numbers. So formula of summation of first summation of cubes of first n natural numbers. We are going to develop that shortcut formula which will be utilized to find out the cubes of the first n natural numbers. So for that, dear students, in the previous lecture we had done a lot of work. So let's to prove, we let bj a sequence, let's say J4. This is a sequence that is named Bj and defined as J4. Now we are considering the difference formula for the consecutive term of this sequence, which, as you know, is defined by Aj Bj plus 1 minus Bj in the previous lecture. Now you see that Bj plus 1, and here Bj is defined as J4. So dear students, I'll replace this J by J plus 1. So I'll get J plus 1 whole power 4 minus Bj, and that is J4. Now I'll just simplify this. So you know that this can be written as J plus 1 whole 2 and J plus 1 whole 2 minus J4. Dear students, opening this by formula, you know well, J square 2J plus 1, J square 2J plus 1 minus J4. Now multiplying these two terms, so you will get J square with this J4, J square with this 2J cube, J square with this just J square, now 2J with this 2J cube, 2J with this 4J square, 2J with 1, 2J. Now 1 with this J square, 2J and plus 1 minus J4. This J4 cancel. 2J cube becomes 4J cube. J square, 4J square, and this 6J square, and we left lastly 2J, this is 4J, and we just left with 1. Now let's take summation. Taking summation on both sides. So for the short shortage of time, I'll consider the summation of this on right and this on the left. J varies from 1 to n 4j cube 6j square 4j plus 1, and on this side j varies from 1 to n aj. Now dear students, you know we have j varies from 1 to n aj was actually bn plus 1 minus b1 in the previous example, and we have developed this in the start of the previous lecture. So we can replace this thing by this bn plus 1, and this can be utilized further as summation j varies from 1 to n 4j cube. Similarly, summation j varies from 1 to n 6j square, and summation j varies from 1 to n 4j, and summation j varies from 1 to n 1. And in place of this, we can replace that by bn plus 1 minus b1. Now, this can be written as 4 square j varies from 1 to n j cube, and this is square 6 j varies from 1 to n j square 4 summation j varies from 1 to n j, and summation j varies from 1 to n 1. And dear student, bn plus 1 by this definition can be written as when we replace j by n, sorry, this, when we replace j by n plus 1, so this will become n plus 1 whole power 4. And similarly, when I replace bj is equal to j square, j with 1, so I'll get 1 power 4, which is just 1. Now dear students, from the previous formulas that I have already developed, you know that this is the thing that to be calculated, to develop a formula for j cube, but this is 6, and already for j summation j square we have calculated that this is equal to 1 by 6 n times n plus 1 to n plus 1. Similarly, this is 4, and the summation of j is, we have already calculated that this is n and to n plus 1 divided by 2, and summation of 1 from 1 to n is just n, and on the right side we left that n plus 1 whole to the power 4 minus 1. Now dear students, these, by the basic mathematics, you can simplify all these things. 6 cancel with 6, 2 with 4 on 2, and then this left material will be shifted to that right side. So we will see that 4 j varies from 1 to n j cube becomes this n plus 1 power 4 minus 1, and this thing will be shifted to that, so minus n plus 1 to n plus 1. Similarly, this will be shifted to that side, minus 2n plus 1, and this n will be shifted, so this becomes minus n. So on simplification, doing the simplification, you can easily find out that we left with n plus 1 n cube 3n square 3n plus 1 minus 1 minus 2n square minus 3n, and further we get that n plus 1, n cube plus n square, and lastly we get that summation j varies from 1 to n. 4 shifted to this side, we get that n square, n plus 1 whole square divided by 4. So this is actually the formula that we have developed for the summation of the first n natural numbers, for the cube of the summation of the cubes of the first n natural numbers. So for this whole process, I just took the series j power 4 defined by j power 4, and this basic difference between the consecutive terms of the geometric series I have considered, because this I have already proved for in the previous lecture. So using the concept of these two and the definition of this geometric series series, so I have further developed that Aj is actually equal to this, and taking the summation on both sides, and I know that Aj summation is actually equal to this. So again we will move forward towards the defined series. So using that one and doing the basic mathematics, lastly we got that if you are needed to calculate the sum of the cubes of the first n natural number, then this is the formula with the help of which you can do it. So dear students, you see, and I'll in the nutshell I'll repeat that, dear students, you must memorize this formula for the summation of the squares of the first n natural number, which is equal to this one, 1 by 6 n times n plus 1 to n plus 1. One is this formula, the other one is just for the summation of n number of natural numbers, and the formula of this is this one. And lastly, I have calculated the summation formula for the cube of the first n natural number, which is this one. So these three formulas are much more important for dealing the summation of miscellaneous series. Along with all these three formulas, we further need the concept of the arithmetic series and that of geometric series, because as I have already said you that in this unit we are going to deal with the summation of the miscellaneous series, and I have already elaborated it that miscellaneous series are those series which can't be grouped in different groups. Here each and every miscellaneous series has properties which are common with arithmetic series, and the same miscellaneous series having some other properties which are common with geometric series. So that's why we neither put these series in arithmetic nor we can consider these are in geometric series. So we are going to deal with these series in different unit, and that is unit number 5. So doing that, we must keep in mind these three basic rules to deal with the summation of the miscellaneous series, and along with these three we must have the concept of arithmetic and geometric series. Now we are going to do a quick some examples to fix the problem, to fix these formula that we have already calculated. And let me do the first example that I am going to do is on the page 163, example number 4. Dear students, here we have a series whose summation is required, but as this is a miscellaneous series, mean it can be either grouped in geometric or in arithmetic series. So that's why we are dealing it here in the new one. So the example number 4 on page number 163. Find the sum of the n terms of the series. Which series it is? This is 1 multiplied 2 square plus 2 multiplied 3 square, similarly 3 multiplied 4 square, and so on in infinite series. Dear students, you see that this is a miscellaneous series, and this miscellaneous series is given that it has the first term 1 multiplied 2 square plus second term 2 multiplied 3 square, 3 multiplied 4 square plus, and so on. Now to find a formula for the summation of n terms of this series, dear students, first of all we need that what should be its nth term, and once we got that nth term, then it is easy to find the summation of the n terms of this series. By considering and thinking of this series, you can see the pattern of this series is 1 multiplied 2 square plus 2 multiplied 3 square. So generally I can the jth term is, you may then consider it Tj. Let me call the nth term or the jth term the general term which actually generates these terms of the series. I am going to consider this is j plus 1. This is j dot j plus 1 square. Why? Because you see, and j varies from j is greater than or equal to 1. It starts from 1. When you put 1, so you will get the first term of this series, and that will be 1 dot 1 plus 1 mean 2 square. 1 dot 2 square for first term. When you put j is equal to 2, this will become 2 dot 3 square. When you will put 3, so 3 dot 4 square, and thus this is a generator. This is the general nth term of the series. Now to find the summation of this series, we are just going to apply summation j varies from 1 to n on both sides. J varies from 1 to n, Tj, summation j varies from 1 to n on j dot j plus 1 whole square. Dear students, we now are going to simplify and to find the nth term formula, summation formula for the n terms of this series. So we are going to do just simple mathematics. This is a plus b whole square formula, which can be written as j square 2j plus 1, and further j varies from 1 to n. This j will be multiplied with this to become j cube 2j square, and thus j. Now we know that this summation can be applied. It has rules that this can be actually written as summation j varies from 1 to n j cube. Similarly, 2 summation j varies from 1 to n j square, and summation j varies from 1 to n j. Now, dear students, you can see that we need the summation of the cube of the first n natural numbers. Here, this is actually representing the summation of the squares of the first n natural number, and this representing the summation of the first n natural numbers. So, I have already developed these summation formulas, and now we are going to just utilize these formulas, and you see that these formulas are for a moment later. I have calculated the formula for the summation of cubes of first n natural number, and you know that I have got that formula is n square n plus 1 whole square divided by 4. Similarly, this is 2, and you know that this formula that actually representing the summation of the squares of the first n natural number, and we have already calculated that this formula is n plus 1 to n plus 1 divided by 6, and thus this formula is n into n plus 1 divided by 2. So, dear students, you have noticed that how this miscellaneous series n terms can be added. We first need the general term that actually generates the terms of this series, that was this one, and then I took the summation on both sides and simplifying one, and we deduce that we need formulas, these 3 basic formulas that we have already calculated. We put all those 3 formulas. Now by simplification, you can do it easily. n plus 1 divided by 12, and this will become 3n square 11n plus 10. And lastly we get 1 by 12, n times n plus 1, n plus 2, 3n plus 5. So this is actually, we have got summation of the first n terms, or summation of the first n terms of this miscellaneous series. And it is so simple that actually when we are going to find the sum of the n terms of the series, we need the general term of that series, and then there is so simple, you have to just apply the summation, and you will require those basic formulas which we have already calculated, and that one, the summation of the cube of the first n natural numbers, square of the first n natural numbers, and just summation of the first n natural numbers formula. When you have these formulas in mind, then there is no difficulty to find the summation of n terms of any miscellaneous series. Now with this, I am going to give you solution of another example. Look at this second one. There is no need of so much hardship, because in the second example we have already given the nth term formula. N term, general term is already given, and we are asked that find the summation of this type of miscellaneous series, that of which we are given you the general term. Example 5, page 163. Dear students, I am just start from solution. Given data, given general term of the miscellaneous series is, what is this? What is that? They have given that the nth term of this series is 2 power n minus 1, 8 power 8n cube and minus 6n square. So they have not mentioned the miscellaneous series itself, but they have just given the nth term formula that actually we need and we require for the summation of n terms of the miscellaneous series. So they have already given us this. So we can replace this by Tj, and there is no problem to represent this by J. And now taking summation from 1 to n on both sides. So this will give you J varies from 1 to n Tj, and thus J varies from 1 to n 2 power j minus 1 8j cube minus 6j square. Now the summation can be applied separately on each term, and this can be further simplified. J varies from 1 to n 2 power j minus 1. This is 8 summation j varies from 1 to n j cube, and minus 6 summation j varies from 1 to n j square. Again, dear students, you can see that here and here we need those two formulas that I have already established. Means a summation of the cube of the first n natural numbers, and similarly the summation of the squares of the first n natural numbers. But you can see here this is actually a geometric series. If you look at this series separately, this is a geometric series, and for the summation of geometric series, you know that we have a formula. Geometric series summation formula is Sn is equal to, you know, a1 2 power n minus 1 divided by 2 minus 1. You know this 2 is common ratio, n is the number of terms, and a1 here you can say this is R. Formula is actually this one. So for this particular series, this term, this miscellaneous series not only involve the geometric series, but the summation of the cube series and summation of the square of the series. Sorry. So here, to add the geometric series, we will apply this formula, and you can see that the common ratio for this is 2. The common ratio is 2, so in place of R we will put 2, and its first term you can see that this is 1, because if you put j is equal to 1 in this one, so 1 minus 1 will be 0, 2 power 0 will be 1. So the first term of this series is 1. The common ratio is 2, and we are to find the nth up to n sum, so this can be written is like this one, and this is 8, and this needs the formula because they are saying that the summation of the cube of the first n natural numbers, so that formula you already know that it is equal to n square n plus 1 whole square divided by 4 minus 6, and this needs the square formula which you have already established, and that is n into n plus 1 2n plus 1 divided by 6. So this 6 will cancel with this 6, and this 4 will be cancelled with this 8 with 2, and this actually gives you 2 power n minus 1, and we left with 2n square into n plus 1 whole square, and minus n plus 1 2n plus 1. On simplification, you will see that lastly you get the total sum of the n terms of this series, which is actually represented by summation j varies from 1 to n tj, and lastly you will see that this whole summation is 2 power n minus 1 plus n into n plus 1 2n square minus 1. This is the formula for the summation of n terms of the given miscellaneous series, but you see that we have already given the nth term formula for this miscellaneous series, and we have just applied the summation and utilizing the concept of the geometric series summation and summation of the cube of the first n natural number and summation formula for the summation of squares of the first n natural numbers, and doing all those, utilizing all those three formulas, we have developed a summation formula for this miscellaneous series. Now, dear students, to make you clear with this, let me solve some questions from exercise. In exercise 5.1, exercise number 5.1, page 164, question number 2, find the sum of one dot two, 2.3, 3.4 plus and so on 99.100. This dot doesn't mean decimal point, this means product. 1 multiply 2, 2 multiply 3, 3 multiply 4 and so on up to 99 multiply 100. This is the given miscellaneous series and we are going to find the sum of this. So how we will proceed? Dear students, first of all we need its general term that actually representing all these terms. So by just considering and thinking over the terms, you can easily find out that actually the general term, general inner term of our kth term, you may call anyone kth term, is this as actually tk, and if I take k dot k plus 1, you can see where for all k varies from 1 to greater than 1 or greater than 1, because if you take k is 1, so this will be 1 and this 1 dot 2. For k is equal to 2, this t2 is 2.3. For 3, this 3.4. So all this whole is actually representing by this nth term, kth term, general kth term of this series. Now we are just going to apply summation on both sides, taking summation. Summation j varies from 1 to, yeah, you may call it k also. This is not necessary that you always represent the general term by j. You can suppose it by k also. So k varies from 1 to n on both sides. And this will become k varies from 1 to n tk, and similarly summation k varies from 1 to n k into k plus 1. Further, next we are just doing basic mathematics, not so much technical. K will be multiplied with this k, so this becomes k square, and k multiplied with 1, so this becomes k, and now applying summation. So summation can be separately written as k varies from 1 to n k square, and summation k varies from 1 to n k. So dear students, here you just need the formula of the squares of the first n natural numbers and formula of the sum of the first n natural number only. And you have already know that this formula is 1 by 6 n into n plus 1 to n plus 1, and this formula is n into n plus 1 divided by 2, n into n plus 1 divided by 2. Now we are just going to simplify this, and you see that here n into n plus 1, n into n plus 1 by 2 is common. So you may take n into n plus 1 divided by 2 is common. Here you will be left with 2n plus 1 divided by 3, and here you just left with 1. So simplifying this n into n plus 1 divided by 2, and here 2n plus 1 plus 3. So this is n plus 1 divided by 2, and here 2n plus 4 divided by 3. So you see 2 is common, so 2n plus 1 divided by 2, and here we left with n plus 2 divided by 3. So 2 cancel, and we just left with n into n plus 1 n plus 2 divided by 3. Thus we have calculated k varies from 1 to n tk, and that is n into n plus 1 n plus 2 divided by 3. So dear students, this is actually general formula for the summation of the miscellaneous series of this. You see that here this series is finished at this last term, and from this you can see that the last term of this is actually 99. Nth term of this series is 99. So you may put this 99 here to get the exact solution of these terms, and that can be that this is 33, this is 100, and this is 101. So you just multiply all these three terms and you will get the sum of all these terms of this miscellaneous series. Next, the rest of the question are suppose that you student will try, and if you have any problem you may ask. For today is enough. Inshallah we will meet in the next class. Thank you. Allah Hafiz.